Hey, what's going on, everybody? Mr. Cornell here in a bright lime yellowish shirt because what we are looking at today is a unit circle, which is the shining light of trig, sort of, kind of, but not really. Okay, it's a really big topic, used a lot. Uh, Not as going to be as difficult as what you might originally think. So I'm going to try to go through it as best as possible to try to ease your pain. Okay. So we're going to look at the unit circle, but before we get there, we have to kind of jump back into some review of a circle, and here is your equation of a circle. And what this is saying is this gives us our center, which in this case would be 0, 0. And then this value here is giving us the value of our radius, which would be 1. Okay? And then that right here is sketched right down here on your sheet. Okay? So here we go. A line segment is constructed from the origin, right there, 0, 0, intersecting the circle at x, comma, y. So there it is at x, comma, y. In quadrant 1, as shown. The line segment makes an angle theta, so that's right here, okay, x-axis, with the positive x-axis label, okay, label theta, and find the expression in terms of x and y for sine, cosine, and tangent, all right? So remember, we are using sine, cosine, and tangent with a right triangle, which we don't have here. But I could make a right triangle by putting a perpendicular line with the x-axis and making this 90 degrees. Now, what's important to realize when I just did that, okay, there's no numbers here, there's nothing for me to measure. So the distance from here to there would be measured on the x-axis, so it's whatever that x value is. The distance from here to here, okay, is this vertical distance, straight up and down, would be the value of y. Right? So now I have something that I could use, right? So if I'm going to go label this, okay, using angle theta, this would be the opposite. This would be the hypotenuse. No, that would be not the hypotenuse. That would be the adjacent side. Undo. Okay, so the hypotenuse is here, opposite of 90, and then this right there. There's your adjacent side. But, all right, I have a distance here, which is y. I have a distance here, which is x. Well, what would the distance here be from the origin to the intersecting point here? Well, that's basically the radius of the circle that we just found to be 1. So this is the value of 1. All right. So if I'm going to find the sine of theta, it would be the opposite over the hypotenuse. The opposite is y. Hypotenuse is 1, so sine theta equals y, because y divided by 1 is y. All right, let's move on here to cosine. Cosine is the adjacent over the hypotenuse. The adjacent side is x. The hypotenuse side is 1. So the cosine theta is equal to x. Tangent theta is opposite divided by the adjacent. The opposite side we just called y. The adjacent side we called x. So tangent theta equals y over x. And then if they said, well, who's x? Well, we just said x is equal to cosine theta. So if I could rewrite an ordered pair now as cosine theta, comma, sine theta, because y is sine. All right, so there you go. Okay, now you're saying, well, what's the point of all of this? Well, we're getting there. Give me some time. So now let's start evaluating here. So they want to know, what is the sine of 90 degrees? Well, now we're starting to look at degrees again, which we had done in earlier lessons. So let's again review back to make sure no one gets lost. So here we have a circle, and we're going to start all degrees at 0, right? And then as I go around, okay, right here, that's going to be 90 degrees. Once I complete halfway around my circle, that's 180 degrees. And then I come around here, that's going to be 270 degrees. And then as I complete my circle, that right there is going to be 360 degrees. And then each one of these degrees is going to land at a certain spot, right? So if I'm saying the sine of 90 degrees, well, 90 degrees is right here. I'm at point 0, 1. Now, we just learned that the sine function is the y value. So what is the y value in the point at 90? 1. That's how this goes. All right, so now same game. Cosine 180 will go around to 180 degrees, see what the point is. So here's the point, -1, 0. And we just said now cosine is x, so the x value there is going to be -1. Same thing, 270, there I am there. Now they want the tangent, which is y value divided by x value. So that's going to be the -1 divided by 0. Now if you go to try to put that into your calculator, it's going to give you an error. So this right there doesn't happen. Okay, you can't have the tangent of 270 degrees. What about the tangent of -180 degrees? Well, if going counterclockwise is positive, going clockwise is negative. So here, there's your -180 degrees. They want the tangent, which is y over x. The y value is 0. The x value is -1. Now, can I do 0 divided by -1? Sure can. So at tangent -180, it is 0 degrees. All right, so if you want to give a pause, try the 4 on the bottom. Go for it, okay? Here we go. Cosine 360 going all the way around 1 time. Cosine is x, so the x value, I'm covering it, is 1, right? Then we're going to go to sine -90. So we're going clockwise over here to -90. And they want the sine, which is the y value. That is going to be -1. Cosine of 0. The cosine of 0 is going to be the x value, which is 1. And let's go around to 900. 1 time is 360. 2 times is 720. And then we hit right around at 900 one more time. And they are looking for the sine, which is y. And that's going to be 0. Okay, so that is kind of evaluating these functions and the points, okay, and just understanding that this is what we have now for sine, cosine, and tangent functions. All right, so now, since theta is an angle of rotation, the terminal side of theta can fall into any quadrant, which will affect the signs being positive or negative of the coordinates x, y, which we just looked at. X is cosine, sine is y. And therefore affects the sign of the trig functions in different quadrants, okay? So what they're basically saying is that when you go ahead and draw some type of angle, okay, and when they say terminal side, it's just basically, this is it here, where the angle is finishing, right? So if I drew an angle here, well, let's do it here, right? This is the terminal side, and it was measured by going around from 0 like this. Okay, so that's your terminal side there. Now, whether it's a sine, cosine, or tangent is going to tell you whether it's going to be a positive function or a negative function. And then there's an acronym that you can use, right? And it says all students take calculus, all right? So in quadrant 1, all trig functions are positive. So if I pick the sine function, the cosine function, the tangent function, okay, they're all going to be positive. Okay, the points are positive in the first quadrant. In quadrant 2, the sine function is going to be positive. And remember, they have their inverses, or cosecant. Quadrant 3 is where the tangent function is going to be positive, and in quadrant 4 is where the cosine function is going to be positive. Okay, and all students take calculus is how you can try to remember that there. All right, and let's do the y, okay, the one thing you care about here. So let's flip the page. Let's take a look at it. So state the quadrant theta must lie in if. So there's some angle. We don't know what the angle is, and I want to know where it is based on whether I'm telling you the function is positive or negative. So they're saying sine theta is greater than 0. So sine is greater than 0. What numbers are greater than 0? Well, positive numbers. Cosine theta is less than 0. So what numbers are less than 0? Negative numbers. So we're saying all students take calculus. All students take calculus. Where is the sine positive? Okay, it's in the first quadrant and the second quadrant. but the cosine has to be negative, so that means you can't be there, so you're right there in the second quadrant, okay? Let's do another one. Tangent theta is going to be less than 0, so he's going to be negative, and the sine theta is also going to be less than 0, so they're both negative. So where is the tangent function negative and the sine function negative? Well, the sine, he's positive there, and the tangent function is positive there. So the only place you're going to find all these guys to be negative would be the fourth quadrant. Okay, and we'll do one more. Okay, positive, 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 all sine, tangent, cosine. So cosine is going to be less than 0, negative. Tangent is going to be greater than 0, so it's going to be positive. So the cosine is negative, the tangent is positive. Well, the tangent is positive here and here, right? But you can't use this guy because everyone's positive, but cosine has to be negative. So where am I? The third quadrant. Right? So that's how you're going to determine where the angle is. So whatever this angle is, okay, it's going to be existing right there in the third quadrant. All right, moment of truth, the unit circle. Fill in the ordered pairs at each of the following angles that are drawn. All right, so this is the unit circle. Okay, just so what they say is they want the ordered pair. So right here, that's a point. Right here, that's a point. Right here, that's a point. And they want to know what is the value of that point. Well, we all know this value because we looked at that before, and that's going to be 1, 0. Okay, it's a physical number you can sit there and count to. Well, how are you going to figure this out? And they're saying that the angle drawn here was 30 degrees. Well, that's where those special right triangles come into play, okay? The 30, 60, 90s, the 45, 45, 90s. So what I'm going to do is I'm going to go ahead and I'm going to fill in this whole unit circle. Okay, you probably won't keep up, so hit pause when you need to so that you can get all of your ordered pairs written down. So here we go. So for starting at 30, I have radical 3 over 2, and then I'm going to have 1/2. Here I'm going to have radical 2 over 2, radical 2 over 2. And then over here we're going to have 1/2, then we're going to have radical 3 over 2. Okay, and then again, okay, this is 45, so they're basically saying, well, that's that. So this is the 45, 45, 90 triangle. Then they're saying this one here, that's the angle, that's 60, and that's your 60, 30, 90 triangle. And again, if you had those memorized, it might be a little bit easier for you to figure out these points. If you just remember those points, then the rest of the circle is easy because you're kind of repeating those points, okay, just changing signs. So if you think about it, what I have here, I'm going to now write over there, but we're going to be reflecting or looking at it now in the second quadrant over the y-axis. So this point here is going to be 0, 1. Okay? Now, watch what I mean when I say that. Over here, okay, this distance is the same as this distance. This height is the same as this height. So this over here is still going to be 1/2 radical 3 over 2, except in the x value, I moved in the negative direction. That's going to be negative 1/2 radical 3 over 2. Same thing here. It's going to be radical 2 over 2, radical 2 over 2, except the x value is now going to be negative because you move to the left. And the last one, 150, is going to be radical 3 over 2, 1/2. Okay, just like over here, except now the x value is going to be negative. So that's that point right there. All right, so now let's move down. Okay, so now again, the points are going to match up. Okay, those points are going to match up. So this guy matched up with this guy, right? So we're going at 210 degrees. So that's going to be negative radical 3 over 2, 1/2. Now, okay, again, the x still moved this way, negative radical 3 over 2. Over here, he moved up 1/2, but over here, he's going to move down 1/2, so that's going to be negative 1 over 2. Okay, here, you're going to have negative radical 2 over 2, negative radical 2 over 2. Because again, we move down. Our y values are going to change. And then our final point here is going to be negative 1/2, comma, negative radical 3 over 2. And there you go. All right, and then that's going to be your third quadrant points. And finally, the fourth, okay, you're matching up with over here. So the distance this way stayed the same. So your x value is going to change, but your y value now is going to have a negative value. So over here, we're still going to be moving over 1/2, but now we're going to be moving down negative radical 3 over 2. Here is going to be moving to the right radical 2 over 2, but now we're moving down radical 2 over 2. And then over here, it's going to be radical 3 over 2, but it's a 3. But we're now going to be going down 1/2. All right, and there's your unit circle. That's how you're going to fill it in. Again, try to remember that first quadrant, those 3 points in the first quadrant, and then you can kind of move around the circle from there. Miss this guy over here, negative 1, comma 0. Miss this guy over here, 0, comma negative 1. All right? And that comes all from the special triangles that we talked about earlier of the 45, 45, 90, and 30, 60, 90. All right, so now let's look at some problems from this. All right, so here's your circle. They drew a triangle here at some angle theta. So in the diagram below, the length of which line segment has the exact value of cosine? So who is cosine? Is cosine your x or is cosine your y? And now what is the x distance? The x distance is OS. And that's simple as that. All right, exercise number 6. Okay, now again, they're saying there are many points on the unit circle besides the one that we just did. So every point, though, must satisfy, well, the equation x squared plus y squared equals 1. So find all values for the y coordinate for a point on the unit circle that has x to be 3/5. So let's substitute. So I'm going to do 3/5 squared. I want the y value is equal to 1. 3/5 squared, 3 times 3, and 5 times 5. Okay, we're going to move 9/25. That's going to be 0.64. We are going to now go ahead and square root that. And then now that can be 0.8. So, but remember, 0.8 squared is 0.64. And then we could do negative 0.8 squared, and that's going to be 0.64 because we're doing square root, so it can be a positive or negative value. All right, so there's 6. And we go down to 7. Okay. An angle theta has a terminal ray that falls in the second quadrant. Stop right there. See if you can draw that. See if you can draw an angle where the terminal ray is in the second quadrant. There it is. Because remember, this is the terminal ray, and there's your angle. And we know that the sine theta equals 3 over 5. We'll determine cosine theta. Well, sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Well, they just told me that the sine is 3/5. So the cosine has to be, well, I don't know, right? So let's go over here. Let's draw that triangle in, right? So what I would have, this would be the opposite side, because opposite is 3. This would be the hypotenuse side. So now, what is this value here? And hopefully, maybe you know it already because you're good with the special right triangles, or maybe you just say, well, I have to do the Pythagorean theorem, and if you did, you would get 4. So this is the value going to be 4. If you go ahead and wrote 4 here and said, well, my answer is going to be 4/5, you would be almost correct, but not totally correct. And there's 2 ways to look at this, right? One is I just taught it to you. One is kind of common sense-ish, okay? We just learned that the trig functions here are all positive. Only the sine function is positive in the second quadrant. That means that this answer has to be a negative answer because he's cosine. But Now you're going to say, well, yeah, you taught me that, but that doesn't make any sense to you, right? Well, let's look at it this way. If you are moving in this direction on the x-axis, what is the value here? Well, you know it's 4, but since you move left, it's negative. So that's why this is going to be a negative 4. So it's negative 4 over 5. And then that's why you're going to make sure you have a negative 4/5 to find the value of cosine theta. And our last question, number 8. Circle O has a radius of 2. An angle with a measure of 30 degrees is in standard position. If the terminal side of the angle intersects the circle at point B. Try to draw that. Draw a circle with an angle of 30 degrees in standard position and mark point B. Okay? Terrible. I tried. All right, so there's your circle. Here is your terminal ray drawn at 30 degrees in standard position. And now this one says that the radius here was 2. It intersects at B. Well, what's his point, right? Well, if you say, well, we just kind of learned that in your unit circle, and at 30 degrees, the point was radical 3 over 2, comma 1/2. So wouldn't this be the same? Radical 3 over 2, comma 1/2. Radical 3 over 2, comma 1/2. And there it is there. Don't get too excited because you're wrong. Sorry to burst your bubble. And why are they wrong? Well, it said the radius is 2. We learned about the unit circle with a radius of 1. So this point exists here, not there. So how did they change that up on you? Well, they made the circle twice as big. So that point moved twice as far. Twice. So take the x point and double it. Take the y point and double it. Radical 3 over 2 times 2 is radical 3. 1/2 times 2 is 1. Radical 3, comma 1 is the point now when the radius is 2, not when the radius is 1. All right, so good work today. Hope that helped. If you have any more questions, leave a comment, like, subscribe, follow, post notifications, all that awesome stuff. Have a good day.